Today we're looking at factor pairs with prime and composite numbers. Now just as a review, prime numbers have only two factors, 1 and itself. Composite numbers are numbers with more than two factors. A multiple is the product of a number and any other whole number. So multiples are always going to be composite numbers. And then last, factor pairs, which is new for this lesson. Factor pairs, two factors or two numbers that multiply together to produce a product. So let's look at a problem. Say this is part of your homework and you need to find the factor pairs of 32. The easiest way to start out with is start out with 1 and the number 1 and 32. Then just go up one by one. 2. Does 2 go into 32? Well, we know that it does because it's an even number and it ends in a 2. Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Well, that was 16. 2 times 16. How about 3? Nope, 3 does not go into 32. 3 times 10 is 30. 3 times 11 is 33. 4. 4 does go into 32. I'm just going to write my multiples out here. 4, 8, 12, 16, 20, 24, 28, 32. So 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8 is 32. What about 5? No, any number by 5 is going to end in a 0 or a 5. How about 6? 6 times 5 is 30. 6 times 6 is 36. How about 7? 7 times 4 is 28. 7 times 5 is 35. 8. Okay, 8 we've got. We could stop there because we're starting to repeat some of our factors. We're finding the factor pairs for 32. There are 3 pairs, and this is what they are. 1 times 32, 2 times 16, 4 times 8. Let's try another. This one's a little bit more complicated, but we can use what we know to solve what we don't know. The following equation is made of 2 composite numbers. Find the composite numbers that would make this equation true. So we're looking for factor pairs of 48 that are both composite numbers. I always pause when I say composite because I have to think about how to pronounce it. Is it composite or is it composite? Well, I say it both ways. Let's write the factors of 48. 1 and 48. 2. Well, instead of counting by 2s, I know that 2 goes into 4 2 times. I know that 2 goes into 8 4 times. How about 3? Yes, 3 does go into 48. Let's see, 3 goes into 4 one time, and there's going to be 1 left over, 18. 3 times 16 is 48. 4 times 12 is 48. Not going to be 5 because it doesn't end in a 0 or a 5. 6 times 8 is 48. 7 times 7 is 49. And 8, well, we've already got as high as 8, so we don't really need to go any higher. These are all of our factor pairs. The directions say to find the composite numbers that would make this equation true. Which of these are composite numbers? That means we can't have primes in here. So let's check. Well, 1 is a prime. Can't use that one. 2 is a prime. 3 is a prime. Okay, so 4 and 12 are both composite numbers because 2 times 2 is 4, 2 times 6 is 12. Well, there's other combinations. And 6 and 8 are both composite numbers. They're both divisible by 2. So there's two different answers that we could have. We could have 4 times 12 equals 48, and we could have 6 times 8 equals 48. Those are our two answers. They're both composite numbers, composite pairs. Okay, I hope this was helpful.